Welcome to Chapter 5, Machine Learning Techniques and Predictive Analytics. Understand the basic concepts of definition of artificial networks. Learn the different types of artificial neural networks. Understand the concept and structure of support vector machines. Excuse me. Learn the advantage and disadvantage of the support vector machines and artificial neural networks. Understand the concept of formulation of k-nearest neighbors. Learn the advantage and disadvantage of KNN. Understand the basic principle of Bayesian learning and native Bayes algorithms. So we're going to start with our vignette. So this is a healthcare issue that's been going on. The population's getting older, more baby boomers than ever, and they have heart issues, heart disease, cardiovascular issues. And the medical world isn't being able to keep up with them. So that's where we're at. That's what this venue is about. So what they did is they figured out that, hey, heart disease is a big problem. How are we going to make sure, can we predict who's going to have heart issues? So they did a study to look at how we can look at the different issues that are going on and how can we put modeling together to figure it out. And as you can see, we used the artificial neural networks, the vector programming, to actually figure out, hey, this is what's going to happen. This is how we can look at what the results are as we start looking at it. So they put this wonderful table together for us, the pros and cons, negative, and how everything comes out. The results showed the power of data mining and predicting the outcome and the analyzing and prognostic factors, complex medical procedures. The research showed that using a number of predictive methods and competitive experimental settings as a potential to produce better predictive as well as exploratory results. So among them, the predictive accuracy was 88%, the information fusion sensitivity, we were able to rank the important of independent variables. Some of the top variables identified in this. So what do we need to get out of this? Managerial standpoint, clinical decisions, systems that use outcomes for data mining are not meant to replace healthcare, but it was help what was going on. So by using data mining, they were able to predict how everything is going. So what is the basic concepts of neural network? Well, neural networks represent a brain metaphor. Our brain can handle so much information better than any of the machines up until this point. These models are biologically inspired rather than exact replicas. Neural networks have been shown to be very promising systems, many forecasting business classifications, the ability to learn from data, to non-pragmatic nature. Neural computing refers to the pattern recognition methodology used in machine learning. Neural networks have been used in many applications for pattern recognition, forecasting, predictions, and classification. Neural networks computing is the key component to any data science and business analytic toolkit applications. Because we covered neural networks, especially the feed-forward, multi-layer, perception type, prediction modeling, neural network architecture. The human brain processes bewildering capabilities for information processing and problem solving that modern computers cannot compete with. And that is our pattern recognition. Biological neural networks are composed of many massive interconnected neurons. Each neuron possesses axons and dendrites finger-like projections that enable a neuron to communicate with its neighboring neuron by transmitting and receiving electrical and chemical inserts, more or less resembling the structure of their biologic counterparts and composed of interconnected simple processing elements called artificial neurons. When processing information, the process eliminates the neural networks, and I have that. Let's see, dendrite, biological, that's what we have. During the last few decades, the exciting resurgence of artificial neural network studies due to the introduction of new network topologies, new activation functions, and new learning algorithms. So as technology is advancing, so are our neural networks. Biological versus artificial networks. The human brain is composed of special cells called neurons. These cells do not die and replenish when a person is injured. The phenomenon might explain why humans retain information for an extended period of time and start to lose it as they get old, as the brain cells gradually start to die off. Neural network architecture. In the mining industry, most of the underground injuries and fatalities are due to rocks falling. The method that has been used for many years in the mines were determined to be integrated by hanging wall and to tap the hanging wall with sounding bars and listened to the sound emitted. Experienced miners can differentiate between solid and detached loose hanging walls. In South Africa, they developed a device that assists any miners making the objective decision when determining the integrated and hanging walls. So this is using the neural networks. There are several neural network architectures designed to solve different types of problems. The most common one include feed-forward, multi-layer perception with back associative memory, recurrent networks, Conan's self-organizing feature maps, and Hope field networks. The feed-forward multi-layer perception type network architecture activates the neurons and learns the relationship between us in one direction. This neural network architecture will be covered and detailed in Chapter 6. So as we look here, we have the input, and an input can be into all different areas, and then we get the output, reoccurring that information. Provides a multi-dimensional data, much lower dimensional spaces, usually 1 or 2 dimensions. One of the most interesting aspects is that it's classified data without supervision. So it allows us to see what's going on. Hope field networks, which is the one on the right, is another interesting neural network architecture first introduced by John Hopefield in 1982. Hopefield demonstrated a series of research articles in the early 1980s and how interconnected networks of nonlinear neurons can be extremely effective in solving complex computation problems. These networks were shown to provide novel and quick solutions to the family of the problems stated in the terms desired objectives subjects. Ultimately, The architecture of the neural networks model is driven by the task it is intended to carry out. For instance, neural networks have been used as classifiers, as forecasting tools, customer segment mechanisms, and general optimizers are shown later in this chapter. Or support vector machines. Support vectors and machines are among the most popular learning techniques, mostly because they support predictive power and theoretical foundations. Support vector machines are among the supervised learning techniques that produce input-output functions from the labeled training data. The function between the input and output vectors can be either classification or a regression. This continues for classification. Nonlinear kernel functions are often used to transfer input data. Data used in the support vector machines have two dimensions. In that case, we would be interested in separating data using the n1, n-1 dimension hyperplane, where n is the number of dimensions. This can be seen typically in the form of a linear classifier, where we are interested in finding n-1 hyperplane. If such hyperplane exists, then the mathematical representation using the quadratic optimization modeling, the hyperplane is known. As we continue to look at it, as technology keeps advancing, new improvements, safety measures are being developed to incorporate into vehicles and roads to prevent crashes, self-driving autonomous cars, and this type of mathematical equations are being used to ensure that it reduces the crashes by making millions of thousands of transactions as fast as possible to help reduce the crashes. Process-based approach to use it due largely to the better classification systems and the support vector machines. Recent have become popular techniques to classifying types of problems, so we're able to look at the data and understand what's going on. Numericizing the data requires that each data instant be represented by a vector of real numbers, hence the categorical attribute. Convert them to numeric data. Basically, we convert things to ones and zeros. We normalize the data, as with the case of artificial neural networks. The SFZ also requires normalization and scaling of numeric values. The main advantage of normalization is to avoid attributes with the greater ranging. Let's see. Our nearest neighbor method for prediction. Data mining algorithms tend to be highly mathematic and computation intensive. The two popular ones that are covered in the previous section involve time-demanding computations, intensive iterative diversions, in contrast with the k nearest neighbor. seems to simplify this. The k-nearest neighbor algorithm is among the simplest of all machine learning algorithms. For instance, in the classification type prediction, a case is classified by the majority vote of its neighbors, and the object being assigned to the class, most common among them, is the k-nearest neighbor. The k is a positive integer. If k equals 1, then the case is simply assigned to the case of its nearest neighbor, illustrated in the figure. So as you can see, the circle, as you move out, set to k. As we move out from the center, we have 3 neighbors, then we have 5 neighbors, and then so on as we go out to see how relevant that is. Same method can be used for regression type predictions by simply averaging the values of its k-nearest neighbor to assigning the results to the case being predicted. We can also use the distance matrix. One of the 2 critical decisions that the analyst has to make while using KN is to determine the similarities measures to make sure that they're very similar in the same area. KN similarity measures is a mathematical calculable distance matrix. Naive-Bayes method of classification. It is a simply probability-based classification method, machine learning technique that is applied to classification type prediction problems. Derived from the well-known Bayes theorem, the method requires the output variable to have a nominal value. Although input values can be mixed of numeric and nominal types, the numerical output variable needs to be discrete via some type of binning method before it can be used in the Bayes classifier. The word naive comes from the strong, somewhat unrealistic assumption of independence among the input variables. Basically, it assumes the variables do not depend on each other or the present. All right. Bayesian network believes that networks of Bayesian network were first defined in the early paper of Judah Pearl, supportive of self-activated multi-directional propagation of evidence that covers rapidly changing. Let's see. Bayesian networks is a powerful tool for representing dependency structures in graphical, explicit, and intuitive ways. Theoretically, any system can be used to model with the Bayesian network. A given model states will occur frequently. And becoming graphical So how does it work? Building problematic models such as the Bayesian network, real-world situation problem using historical data can predict what's likely to happen when something else would have happened. Essentially, BN typically tries to represent interrelational among the variables using problematic structures that often called joint distributions. For complex models such as tables can easily become rather large because it stores one probability value in combination with another. And how we can construct these? There are two common methods available to construct a network: manual and help domain experts. Analytically, by learning the structure of the networks from the historical data by using advanced mathematical methods, building a network manually. Assembly modeling is a combination of output produced by two or more analytic models into compound output. Assemblies are primarily used for prediction modeling when the scores of two or more models are combined to produce a better prediction. The prediction can be either classification or regression estimation. Although the use of assembly has been dominated by prediction type modeling, it can be also used for analytic tasks such as clustering or associated rule mining. This is modeling, and assembly can be used for supervised as well as unsupervised machine learning. These machine learning procedures focus on identifying and building the best possible model. Usually researchers and practitioners build assembly for two main reasons: for better accuracy and more stable, robust outcomes. Numerous research studies and publications over the past 2 decades have shown assembly almost always improves predictive accuracy and given problems, and rarely predict worse than a single model. Assembly began to appear in the data mining analytic literature in the early 1990s, motivated by the limited success obtained by the early works of combining forecasting and data. By the early 2000s, assemblies had become popular and almost essential to winning data mining and predictive modeling competitions. One of the most popular awards for assembly competitions, perhaps the famous Netflix prize, which is open to competition, soliciting researchers and practitioners to predict users' ratings of a film based on historical rating. The prize was $1 million for a team that could reduce the randomness of then existing prediction algorithm by the largest margin, but no less than 10%. Assembly, or teams of predictive modeling working together, has been fundamentally strategy for developing accurate and robust analytic models. Although assemblies have been around for quite some time, their popularity and effectiveness have surfaced in a significant way only within the last decade as they continue to improve the parallel with rapid improving. When we refer to the model assembly, many of us immediately think of decision tree assembly making like random forests and boosted trees. However, generally speaking, the model assembly can be classified into 4 dimensions. The first dimension, homogeneous, bagging, boosting, and heterogeneous, simply complex weighing, rare activities, so we can see what's going on. Bagging is the simplest and most common assembly method. A very well respected scholar. The idea is quite simple yet powerful. Build multiple decision trees from a resample data and combine it to predicted values through averaging or voting. The sampling method used as a bootstrap sampling. Boosting, perhaps the second most common assembly method after bagging. The idea behind boosting is also quite straightforward. First, build a rather simple classification model. It needs to be only slightly better than a random chance. So if your binary classification problem, it needs to only be slightly better than 50% correct. Each record is used in the algorithm with equal case weights to allow it to happen. All right, so what did we cover in this week? We looked at the neural computing involves a set of methods that emulate the way the human brain works. The basic processing unit of the neuron, multiple neurons are grouped into layers and linked together. There are differences between biologically and artificial neural networks, and the artificial neural network knowledge is stored in the weight associated with each connection between two neurons. Neural network applications abound in almost all businesses. Business applications of neural network include finance, bankruptcy, prediction of what's going on. There are various neural network architectures. The CVM, among the most popular machine learning techniques, although the SVM can be used to both classification and estimation regression type predictions. Nearest neighbor we looked at, determining optimal thing. Bayesian classifiers are built on the foundation of the Bayes theorem. Naive-Bayes is a simple probability-based classification method that is applied to classification. The Naive-Bayes allows us to look at that. Our homework for this week, your assignment, Chapter 5, discussion questions 1 through 4, Exercise 6, and Internet Exercise 7. You're going to write your paper in APA. Your discussion question, which is due Wednesday night, is what is the relationship between Naive-Bayes and Bayesian networks? So that's what we're going to be working on.